Hey guys, welcome back to another Sprouting into STEM video. Today I'll be introducing you guys to the basic trigonometric ratios. These three basic ratios are sine, cosine, and tangent, and they represent the foundational trig ratios. You will build off of these as you move on in your careers, and these will play a huge role in your understanding of other subjects like physics. So first off, these trigonometric ratios allow us to find missing sides of a right triangle and missing angles. This is only for a right triangle, remember that. And another key point is, regardless of the size of the triangle, these ratios will hold true for any right triangle. These three ratios are sine, cosine, tangent. Alright, here we go. Alright, first off, let's review what a right triangle is. So here I made a right triangle diagram for you guys. First off, every right triangle obviously needs to have a 90-degree angle. So here's our 90-degree angle for this triangle. And also, the other two angles will be acute angles because they have to be less than 90 degrees. And then it'll also have three sides because obviously it's a triangle. So there's the opposite leg, the adjacent leg, and the hypotenuse. So the opposite leg is always opposite of one of the acute angles. In this case, this is our acute angle right here, and this is the opposite leg. The adjacent leg is next to the acute angle, just right here. The hypotenuse is opposite to the right angle, so here. But in other cases, it's always the long one. So we can remember it as these three legs will be key in using these three ratios. So now, we need to solve for the missing sides and angles using the three ratios we have. So first off, there's an easy acronym we can use to use the three basic ratios to solve for the missing sides and angles. That's SOH CAH TOA. Right here you can see SOH CAH TOA. So I made the first letter of each of these acronyms a different color, which is pink. So that stands for the basic ratio in each. So look, S is sine, C is cosine, and T is tangent. So we can use that to memorize what how the ratios work. So first off, sine. This is how the sine ratio works. Use the opposite side of the triangle over the hypotenuse. So use the lengths of both of those sides and find the ratio of those. You do that for the cosine also, but use adjacent instead of the hypotenuse length. And then you also find the ratio of that. And then for tangent, use the opposite leg and the adjacent leg and find the ratio of that. So this is all about ratios of the lengths of the triangles. We use the lengths of the triangles in these ratios. Remember that. So again, for sine, use the opposite leg's lengths over the hypotenuse length. Use the adjacent length in cosine over the hypotenuse length. And in tangent, use the opposite leg length over the adjacent leg length. Remember, SOH CAH TOA, that's going to be key. And advice I have for you guys is before like a homework assignment or something, just write this acronym on top of your sheet. It'll help you guys out a lot. Here I made a quick diagram of how to show these ratios working in a right triangle. So first off, right here we have a right triangle, and the capital letters I made are the angles. So you can see right here, A is this angle, C is the right angle, and B is this angle right here. And the lowercase letters are the sides. So this is the A side, the C side, and the B side, or legs, you can call them. And also wrote SOH CAH TOA on top of here. Remember, that's the acronym we use to use these ratios. So first off, you can see we're using this angle, sine of A, so that's sine of this angle, right? And to solve for like a missing side, we would use the ratio A over C, because that's the opposite. That's hypotenuse. Remember SOH CAH TOA, opposite over hypotenuse. And then cosine of A, right here. This ratio will be adjacent over hypotenuse. So adjacent is right here. That's B over C, which is the hypotenuse. And tangent, that ratio is opposite over adjacent. So opposite is A and adjacent is B. So that ratio is A over B. So if you guys want to pause the video right here and see how these ratios work with the angle of A. You can also use any other angle and also do the same thing with that. But not any other angle. You can use angle B, not C, because it's a 90-degree angle. Now time for some examples. So here is an example of how we can use these ratios to solve for a missing side. So the missing side in this case is r. R is the missing side, which is the hypotenuse in this case. So which values do we have? We have an angle and another side length. So which side length do we have if this is the angle? Remember, we always base our side lengths, or like definition of side lengths, off the angle. So in this case, it's this angle. So this angle, this side will be the opposite side, right? Because it's opposite of the acute angle, and this will be adjacent, and this is the long side, which is going to be the hypotenuse. So which trig function uses the opposite and hypotenuse? Well, if we go up to here, we can see opposite hypotenuse, right? So that's S, which is sine. So that means it's sine 20, right? Because sine, that's the angle. So sine 20 equals a ratio, opposite over hypotenuse, which is 10 over r. That means we got the ratio 10 over r is equal to sine 20. But we're solving for r, right? So that means we need to get r by itself. How do you do that? So first off, you multiply r to get it on this side of the equation. So I did that here and got r sine 20 equals 10. So then you have to get r by itself, so you divide sine 20 from that. 10 divided by sine 20, right? So r is equal to 10 divided by sine 20, right? So here, now we get our calculator out. First off, make sure your calculator is in degrees, which mine is. So now we do sine 20, right? So that's that. So then we do 10 divided by this, we get 29.238, right? Round that up, we get 29.24, which is correct. And that will be the length of the hypotenuse. Another way to make sure your answer is seems correct is if the hypotenuse always has to be the longer side, because it's the longest side in the triangle. In this case, 29.24 is longer than 10, so that makes sense. So this example uses sine. The next example will also show another basic trig function. Here's our second example. So I have another right triangle here, as you can see. Sorry I didn't write the right angle here, but it is a right triangle. And we have an angle of 38 degrees now, and we have another side with 60. But we're solving for this side now. Okay, so this is not the hypotenuse. We can rule that out because it's not the long side. The hypotenuse is right here. And then the opposite side is 60, obviously, right? Because it's opposite from the 38 degrees, which is the acute angle. So this has to be the adjacent side. And we can also tell that because it's right next to the acute angle. So what trig function uses the opposite side and the adjacent side? So we're going to go back to SOH CAH TOA up here. And we can see what uses the O and A. That's the TOA right here. So tangent. So then we use tangent of 38 right here is equal to the opposite over adjacent. So opposite 60 over x. So 60 over x. So again, we have to get x by itself. What do? Bring it over here. So multiply x times tangent over 38 equals 60. To get it by itself, again, we have to divide by tangent of 38. So x is equal to 60 divided by tangent over 38, right? So here, I'll get my calculator out again. So we use tangent 38 right here, then 60 divided by our answer, get 76.79. Round that up, get 76.80. So again, this is a right angle. We used tangent because we had to use the ratio of opposite over adjacent. So this is our last example of how to use SOH CAH TOA to solve for the basic trig functions. We can use these trig functions to also solve for a missing angle. That can be a future lesson. And also, this is going to, like I said before, this is one of the stepping stones to the world of trig. This is one of my favorite topics, and I hope you guys enjoy. If you guys have any questions, let me know, and thanks for watching.